Earth. Home. The third blue rock from the Sun, the only known planet where life can thrive. We have around 78% nitrogen, 21% oxygen, and 1% argon, water vapor, and carbon dioxide, give or take. The perfect balance to support our respiration. The troposphere is the lowest and densest part of Earth's atmosphere, 5 to 9 miles thick. It's the part of the atmosphere that keeps changing our weather. For any life to exist, we would need this atmosphere and the same combination of gases to breathe. If all the planets in our solar system were combined to become a mega-Earth, then humans wouldn't have evolved the way we are today, and we'd have a very different planet. If we take the landscape of Mars, we'll only have solid land without large bodies of water. Earth is the only planet in our solar system with bodies of water. One of the first wonders to see will be Olympus Mons, the largest volcano in the solar system. It towers Mount Everest by a long shot at 78,000 feet above the ground. Velis Marineris is a group of canyons that make the Grand Canyon in the U.S. feel like a average one. This wonder stretches for almost 2,500 miles and goes more than 4 miles deep. On top of these epic terrains, there's plenty of other grand-scale locations on Mars that are way bigger than the ones on Earth. The planet might be as large as Jupiter. If the Earth were the size of a grape, then Jupiter would be the size of a basketball. We'd have the size of Jupiter and the rings of Saturn floating around us. The rings may seem like some large chunks of rock in the air, but they're actually ice particles and chunks of iced rocks. They range from the size of pebbles to car-sized ones. Saturn's rings are supported by the unique gravity in the region. With a lot of these ice rocks floating in the sky, there won't be much sunlight entering the planet, which means the planet will always be colder than usual. Not to mention the many moons it has. Our megaplanet could also have many moons circling above us, contributing to the tidal waves. Jupiter is known for the red spot, a place twice the size of Earth that has hurricane-like storms that have been going on for hundreds of years. The people of Mega-Earth will settle far away from it. Mercury is a planet but looks like the Moon due to all the craters lying around. That's because of many asteroids and comets striking it over billions of years. But the landscape here mainly consists of mountains, highlands, cliffs, and valleys. The Caloris Basin is almost 1,000 miles wide. They believe it was formed by a comet. The deserts on Earth are mainly hot and consist of dunes of sand, but they also have flat plains and small hills. The largest desert in the world is the whole Antarctic continent. Mercury has no atmosphere to trap any heat, so it gets really hot when the sun is facing it and freezing cold when the planet turns away from it. On this combined mega-Earth, the desert will most likely have a similar landscape to that of Mercury. The animals living here will probably be something like giant scorpions and desert snakes that soak in some sun during the day and go out hunting at night. But the soaring day temperatures would melt anyone walking. And even though Mercury is the closest planet to the Sun, it's not the hottest. Venus has temperatures of nearly 900 degrees Fahrenheit. Scientists believe that the lands here are flat because of the extreme temperatures, but it's not all flat, with some volcanoes and highland areas. We can probably find this terrain and climate near the equator, since it's always hot there. Humans can't live there unless they build special domes to sustain life. But since the planet is now huge, not all its territory needs to be populated. Some areas will have the proper atmosphere for breathing, but some places might not have such luxuries. Over at the poles, the climate will most likely mimic Pluto's, even though it's not technically a planet anymore. In 2006, they officially declared it a dwarf planet, and it's even smaller than the Moon. There's not much known about this little mini floating rock, except that it's composed of around 70% rock and 30% ice. Scientists believe that a part of its surface is covered in frozen nitrogen, solid methane, and carbon dioxide. Since the megaplanet is huge, gravity might be quite strong here. Jupiter's gravity is enough to double your weight. Humans will most likely be really tall and mega-sized to match the big planet. Even the oceans will be huge. Our oceans will look like little lakes compared to what Mega-Earth has in store for us. Humans need something close to 24 hours in a single day. Our bodies adjusted to it quite well, But it wouldn't affect us too much if the day had a few extra hours or a few hours less. We can't live on any other planet without wearing the proper gear. We wouldn't last more than a few seconds in places like Jupiter, Neptune, and Saturn. It's possible to last as long as you can hold your breath on Mars. The atmosphere is thin and the gravity is similar to ours, but you might freeze. Even though it's a red planet, it's actually very cold and has ice caps in the poles covered with carbon dioxide. The same's true for Mercury. You can only last there as long as you can hold your breath and be in the sweet spot between the sunrise and the sunset. Ancient civilizations wouldn't have been as diverse as they were on Earth, since the extreme terrains and conditions wouldn't have allowed for discovery and trading. But eventually, as humans developed special technologies for certain areas, different cultures would emerge. Many animals would also evolve in specific and unique ways, but because of the planet's enormous size, isolation, and being on top of the food chain would let certain animals be around since the beginning of the planet without evolving. So it's possible that this mega-Earth might have ancient dinosaurs roaming around, and they'd be even bigger than the ones on Earth. And even though there's a high chance that some humans might be physically different than each other, there might even be more than one species of humans living on opposite ends of the planet. Because of the isolation, they evolved in their own ways according to their surroundings. Over the centuries, technological advancements would spread different cultures around, and we'd be more open to each other. Neanderthals and Homo sapiens once lived side by side and were considered as the two species of humans. Neanderthals were intelligent and used tools for hunting and drawing. Homo sapiens were survivors and wandered around to discover new land. There could be two dominant human species and other minor ones that live in certain areas on Mega-Earth. They'd be bigger, tougher, and faster than us. The ones who live by the trees would have elongated limbs to stretch out and swing from tree to tree. The ones that live in savannas will probably run really fast and have long legs for that. Countries and cities will be bigger than what we have on regular Earth. A country can be as big as Earth itself. The human population can reach tens of billions. Special transportation technology might be invented for people to travel from one continent to another. Covering those distances can take months or even years if using regular aircraft. High-speed trains that travel so fast over land and rocket-like planes going through the sky. Traveling through oceans will require extremely sturdy ships. Traveling through the Atlantic Ocean is already scary for many, so imagine going on a voyage across a body of water that's potentially 8 times the size of Earth. We're going to need a bigger boat. There'll be areas to avoid, like the red spot with its perpetual storms raging on, but the tourist industry might have some room for anyone who wants to see it. Living on such a huge planet is unlikely going to become a reality for most of us anytime soon. But scientists are already discussing moving to other planets to find a new home for humans.
The Milky Way is one of the biggest mysteries out there, literally. It's hard to figure out how big our home galaxy is. And one of the main reasons is because we live in it. Think of it as walking around a mall. You can tell it's big, but you can't be certain until you actually see it from a bird's eye view. The Milky Way consists of billions of distant stars that look like a string of lights from afar. So you just need to measure the distance between these stars and voila, you have the answer. Not really. I might have forgotten to mention opaque clouds of dust blocking your view. Some scientists were stubborn enough to run computer models of how galaxies form and evolve. There's a halo around our galaxy. So the scientists wanted to see if there was some sort of a dead end in the Milky Way. They found out that the Milky Way spreads for 100,000 light years away from its center. It likely means that the entire galaxy is around 200,000 light years across. The problem with this estimation is that halos don't tend to have some final border since they simply fade away. It's like pointing a flashlight and trying to see precisely where the light ends. In 2013, The Hubble Space Telescope captured an image of something 25 million light-years away. It turned out to be a spiral galaxy, later called SO 3738, with at least 7 other galactic neighbors. And this galaxy is as thin as a pancake. A very shiny pancake. The telescope also took a photo of another galaxy cluster 65 million light-years away. It was called IC 335. It's another glorious glittering pancake floating in the vastness of space. The images the telescope took aren't the most accurate. It's hard to tell what exactly you're looking at. These disk galaxies have lots of dust clouds that can stretch for hundreds of light years across. They're mainly located near the centers of galaxies and are invisible in regular light, but they can be detected with the help of a blue filter. Anyway, this IC 335 galaxy is an oval disk with huge clouds of gas and dust. This means stars constantly appear there, but not all galaxies create stars. A galaxy is born as a giant ball of slowly rotating gas that is steadily collapsing in on itself. As it starts spinning faster and faster, the pancake shape is formed. Ooh, pass me the syrup. It's like spinning pizza dough in the air after rolling it into a ball. The topping is stars and the sauce is clouds of dust and gas. Are you getting hungry like me? Some galaxies can lose their gas and dust if they become part of a galaxy cluster. Then, all these mini galaxies orbit their common center of mass, with gas separating them. When a disk galaxy dashes through them like a speeding train, the pressure can blow away this dust and gas. From far away, it looks like you're staring at a DVD you're about to play. But if you traveled millions of light years to get a closer look, you'd see a dim disk filled with stars. You wouldn't even be able to tell you're inside it. You'd also see a bright blob of dust left by the red giants in the middle of the galaxy. Red giants are massive and very bright stars with low surface temperatures. But the images of these galaxies don't actually show us their real color. Cameras make up some of these hues so that you don't have to look at something fuzzy or grainy. People don't actually know the real colors of distant galaxies. Our galaxy has a lot of gas inside, like me, so we don't need to expect our home to dry up anytime soon. In fact, the Milky Way still produces new stars, around 7 a year. But some galaxies fade out when they can no longer create stars. In the industry, they call it strangulation, and it happens when galaxies run out of gas, which means there's no more new material that can be used for star making. Search. Gas and dust aren't the only things you can find in a galaxy. Just like a magician pulling a rabbit, flowers, and other things out of their magic hat, galaxies have other surprises, like planets, those balls of matter spinning around themselves and around other things. Well, technically, planets are far from being perfectly round in shape, but they aren't also flat like spiral galaxies. It's mostly because of gravity. Its force is so strong that a planet pulls everything toward its center, taking the shape of a sphere. In the process, all the edges and anything else that might stick out get smoothed out. But the smaller a space body is, the less round it is. Take a comet. It doesn't always have a smooth surface. It's small, and therefore its edges are rugged and pointy. Given the size of Earth, it's safe to say the gravity is strong here compared to that of the moon, or any smaller-sized space object. And because of our planet's constant rotation, there's an outward bulge on Earth. This tug-of-war between the gravity pulling inward and the planet's spin doesn't allow Earth to be a perfect ball. On top of Earth not being a perfect sphere, the planet is also tilted. This design flaw is responsible for the seasons we have. This tilt could happen because millions of years after Earth was formed, it probably collided with a protoplanet, a large space body developing into a planet. Venus is unique because it rotates backward compared to the rest of its peers. If you were standing on Venus, the hottest planet in our solar system, you'd see the sun rise in the west and set in the east, but you'd have to make it on time to observe this phenomenon. A day on Venus lasts for more than 240 Earth days. For a long time, scientists believed that the sun's strong pull on Venus was responsible for such a long day, but new theory claims that Venus used to spin just like Earth and the rest of the planets. But at one point, it just flipped its axis 180 degrees. It doesn't mean the planet abruptly stopped halfway through the rotation. and started to move backward. One theory suggests that a large comet or object struck the planet in the past. This might have caused it to change the direction of its rotation, but many scientists doubt this theory. If you observe the moon for some time, you may notice that it's the same face staring at you every night. The truth is, the moon does rotate, but very slowly. It takes our planet's natural satellite 27 Earth days to rotate around its axis. Plus, the moon rotates at the same rate that it orbits Earth. The side we always see is called the near side of the moon, and the side that's not facing us is, you've guessed it, the far side of the moon. It also has the nickname, the dark side of the moon. Uranus's rotation axis is 98 degrees relative to the plane of the solar system, which basically means that the planet spins on its side. For a while, scientists believed that a large object firing through space knocked into Uranus, causing it to tilt. But here's one problem. Uranus's moons are covered in ice. A collision so powerful that it made the planet tilt would have resulted in disrupting the moon's movement and their position. But they seem relatively untouched, and all the ice covering them is still intact. But any major changes happening with Uranus would have generated enough energy to melt the ice. Another reason for Uranus's strange position might be its rings. Yup, Uranus has rings just like Saturn, except they're lighter and fainter. Saturn's rings are mostly billions of chunks of ice and rock floating in orbit. Some particles can be the size of a pebble, while others can reach the size of a house. Wow. Other particles are broken up comets, asteroids, and moons torn apart by Saturn's gravity. If you observe the rings from afar, they look like colorful stripes made up of thousands of different streaks, but there are actually only 8 layers of rings. Uranus might have had rings that were just as glorious as Saturn's around 4.5 billion years ago. The balance between Saturn's gravity and its rings might be responsible for keeping the planet upright so that it doesn't tilt over. If Uranus had the same rings, they could prevent the planet from toppling over. The way to solve Uranus's tilting problem may be for the planet to get its rings back. They would help Uranus keep its balance. On the other hand, hey, we like it just the way it is. As you know, all the planets in our solar system orbit the sun and bring a sense of order to the place. But guess what? There are 2 planets that could collide with each other and cause a cosmic catastrophe. Here's Neptune, the most faraway planet in our solar system. It's 17 times heavier and 4 times bigger than the Earth. It's 30 astronomical units from the Sun, 30 AUO. 1 AU is the distance between the Sun and the Earth. So it's 30 times farther away from our star than we are. And Neptune makes a complete circle around the Sun in 164 years in an almost perfectly round orbit. Neptune is cold, calm, and stable. But there's one planet that can ruin this balance: Pluto. It's a dwarf planet covered in rocks and ice. It's 6 times lighter and 3 times smaller than the Moon. We're interested in its orbit. If you look at a map of the solar system from above, you can see that it's not round but elliptical. So it's a slightly flattened circle, 49 AI. At its furthest point, Pluto is 49 Earth-sun distances away from the Sun. When it moves, it comes closer to the star. At its closest point, Pluto is about 2912 AU from the Sun. That's closer than Neptune. So hypothetically, they could collide. Let's look at this collision from the front row. A little closer, please. Good. Neptune and Pluto are slowly approaching each other. They are both very cold worlds, but they begin to interact with each other gravitationally, just like 2 magnets. It warms them up from the inside. Neptune is a gas giant. There's no solid surface there, so there's not much change in it yet. But Pluto has a rocky surface. Because of Neptune's gravitational influence, it's starting to crack. Pluto experiences continuous earthquakes. This causes it to heat up even more. When Pluto almost touches the gas giant, it begins to crumble from the inside out. Plus, Neptune has a very dense atmosphere, so the dwarf planet begins to ignite from friction with the gases in the upper atmosphere. Pluto is now very hot on one side and very cold on the other. This causes severe deformation, and it begins to crumble. Half of the dwarf planet's fragments remain in Neptune's orbit. They will collide with each other until they turn into dust and and become new rings of the big planet. Other fragments will burn up in Neptune's atmosphere, and the biggest rocks that remain of Pluto will fall through Neptune until they're completely burned into dust. Neptune literally ate Pluto and continued its orbit without any change. All because the gas giant is 20 times larger and much heavier than the dwarf planet. So, this collision would do no harm to Neptune. But it couldn't have happened in the first place because their orbits don't actually cross. All 9 planets here are on a horizontal line from the Sun. The distance between them is great, and their orbits don't cross. Here's Pluto's orbit. It starts at the top, then dives under the orbits of the planets and comes back, so Pluto can never collide with Neptune. Still, planetary collisions have occurred in our solar system before, and thanks to these collisions, life appeared on Earth. Let's go back in time to almost 4.5 billion years ago. This ball of hot lava is Earth. It's just formed from a cloud of dust and begun to cool. But then, a wandering planet the size of Mars appeared on the horizon. It's called Theia. It was inevitably approaching our planet. The collision with Theia happened at a perfect angle. If Theia had hit us head-on, both planets would have been smashed to pieces, but it hit us almost at a tangent. Theia knocked some of the matter out of the young Earth and crumbled into rubble itself. It could no longer continue its journey because the Earth caught it in a gravitational trap. A large fragment of this planet remained in our orbit. Smaller fragments crashed into each other, falling to Earth or joining the remains of Theia. The dust settled, and we can see the familiar picture, the Earth and the Moon. This is the main theory of how it came to be next to us. Scientists say that it was this collision that caused life to appear on Earth. Theia brought a lot of ice on it, which turned into water on our planet. The new moon stabilized Earth's rotation, and conditions on the planet became perfect for the emergence of life. Another collision could create a blast wave that would spread out thousands of light years. Stellar collision. This usually occurs in binary systems with a white dwarf and a regular star, like our Sun. A white dwarf is the remains of a star that has gone out. As the stars get closer, they start to move around each other in a spiral-like dance. The white dwarf pulls down the upper layers of the larger star. This hot plasma and stardust form a luminous disk. The two stars get closer and closer. When they finally merge, this causes a chain reaction in the core of the hot star. The mass of matter presses on the star's core too hard. This causes the innards of the combined star to heat up even more, and it expands, creating a supernova. The light from the explosion can be seen hundreds of light years away. Another spectacular view is the collision of a star with a black hole. Black holes are the heaviest objects in the universe, and their gravity is incredibly strong. So when a star and a black hole get close, the black hole starts eating the lighter matter of the star. The hot plasma, like spaghetti, heads toward the heart of the black nothingness. For an observer, this plasma seems to settle on the very edge of the black hole. It's called the event horizon. The thing is that time is much slower near such a heavy object, but in fact, it's long gone into the heart of the black hole. As they get even closer, the black hole starts to literally tear the star apart and swallows it whole. At this point, the black hole spits out about half of the star's mass in the form of a beam of energy right out of its black heart. The other half of the star's mass becomes the black beast's food. We know of many black holes in our universe. The heaviest of them usually lie in the centers of galaxies. They can be millions of times heavier than the Sun. Our scientists had the opportunity to observe such an event. Two black holes weighing 66 and 85 solar masses gradually approached each other. They danced together, bending the light passing by them. But then, they merged into one enormous black hole, weighing 142 solar masses. That same second, the new black hole released gravitational waves into space with an energy of 9 solar masses. Scientists were able to catch these waves and observe the merging of the two black holes from the front seat. But this event actually happened about 17 billion years ago. We're only now seeing it because the particles of light and gravitational waves took so long to travel the distance of 17 billion light years to Earth. Now, consider a galactic scale collision. Literally. It's a collision of the Milky Way and the Andromeda Galaxy. This event will happen in 4.5 billion years, so stay tuned. The Milky Way has about 100 billion stars. Andromeda has about 1 trillion. As the galaxies approach one another, they will make several circles around each other. At that time, some stars may be ejected from the galaxies, like from a slingshot. Then, Milky Way and Andromeda will begin to merge. One scenario here is that our solar system will collide with another star system from Andromeda. In this case, there could be a stellar collision and a supernova afterwards. Our world would be destroyed. Another option is that the sun would be ejected into dark space. In this case, we may not even notice the difference. All we'll see on Earth is a gradually disappearing starry sky, as our solar system will travel through dark space away from the home galaxy. But the most likely scenario is when the galaxies merge, it'll be completely painlessly for us. In fact, the space is very wide, and there's room for all the stars from both galaxies. The only difference is that we'll see a lot of new stars in the night sky, along with flying saucers from Andromeda. No, not really. But it's not the collision of galaxies that we should be worried about. It's our sun. In 4.5 billion years, it'll become a red giant. It'll expand, swallowing up the nearest planets. Earth will probably be the first planet near the sun. It'll be so hot that all life will simply disappear, and no one will be able to watch the galactic collision. There are thousands of satellites flying around Earth. Some are needed to provide communication and others monitor the weather and climate changes. In 2009, one of these satellites was circling our planet and scanning the waves reflected from the Earth's surface. The satellite was looking for changes in the emission of carbon dioxide coming from the planet, but it found something else, something that completely changed the principle of studying the Earth's ecosystem. The source of the wave was utterly unknown. Scientists wanted to know the nature of these waves, so they tuned the satellite's instruments to the desired frequency and looked at the Earth. At that moment, they saw an unknown red glow surrounding our entire planet. In some places, the glow was weak, and while in others, it shone brightly. At first, everyone assumed that it was sunlight reflected from the Earth and produced unknown red particles. However, the analysis showed the glow's source was on our planet, and it never came from the sun's atmosphere. The glow may be the result of humanity, city lights, exhaust, fumes, or something else. But again, scientists made a mistake. The brightest red light was radiated from places without humans. There were no traces of modern civilization. It turned out those places were swarming with plants. The brightest waves come from the Amazon jungle, croplands of the Midwestern US, northern evergreen forests, and other green areas. To understand the cause of the planetary red shining, scientists began to restudy plants. Every living tree, leaf, or blade of grass absorbs carbon dioxide and produces oxygen necessary for life. Plants manage to do it thanks to their ability to absorb sunlight. This process is called photosynthesis. New research showed that every plant emits a red glow during photosynthesis. It happens because they don't absorb all the incoming sunlight. They give part of it back in the form of a red glow, and this part is only 1% from all the receiving sunlight. This small amount of red light is impossible to see with the naked eye, but if you look at millions of plants from afar, the wave can be noticed. But still, with the help of special devices, this new photosynthesis process is called chlorophyll fluorescence. This is a hugely important discovery that allows people to monitor the state of nature. Previously, changing the color of trees helped us understand that something was wrong with the forests. For example, if a tree turns yellow, then it's probably not healthy, and we could observe the plant's state through satellites. But there are many exceptions to this method. In autumn, in many regions, almost all trees turn yellow and shed their leaves. But in any case, this monitoring system is not very effective. If we see an unhealthy tree because of its yellow leaves, then it's already too late to cure it. Any change in the red glow allows determining problems with the vegetation before the leaf color changes. And this helps to do something just in time. With the help of satellites satellites, people can now see the problem areas of the planet. Also, the glow helps understand how much carbon dioxide and oxygen trees emit. We can learn about the plant's problem even before it occurs. The glow also comes from seaweed and phytoplankton. More than 50% of the oxygen in the atmosphere comes from oceans. Theoretically, it's possible to scan other planets in search of the red glow to understand which of them has a habitable atmosphere. The red glow doesn't only come from our planet. In the depths of outer space, through a telescope, you can see the Horsehead Nebula, one of the most beautiful places in the universe. It's located in the constellation Orion. People called it so because of the similarity with the thrown-back head of a horse. This nebula was first discovered in 1888. This huge area of space is illuminated with a rich red color. This beautiful shining is possible because there are many super powerful blue stars inside the nebula. Their energy is absorbed by one of the most common substances in the universe, hydrogen, H2. Hydrogen atoms receive such a strong charge from super powerful stars that they emit red light when they collide with electrons. Just imagine if a super powerful star was burning near our solar system, or if our planet was located in the Horsehead Nebula, perhaps we wouldn't notice the red glow, so we would live inside this glow. We can observe beautiful multicolored nebulae only from the side, being thousands of light years away from it. Let's go back to our planet. By the way, there's another amazing glow surrounding Earth. It seems to be pulsating, shimmering with different colors, constantly changing its shape. If you look at our planet through special equipment, you will see that it's located inside this pulsating, uneven bubble. The bubble layer is quite thick. It covers the planet at an altitude of 5,400 miles, 50 mixi, or 80 km, or 400 miles, or 640 km, or above the surface. Even the International Space Station flies inside this glow. Almost all the satellites surrounding the Earth are in the zone, too. It's called the ionosphere. It ensures the operation of communication and navigation systems. It helps radio signals and jeeps to get to our mobile phones. The ionosphere is a layer of charged particles that separates the upper layers of the atmosphere from pure space. In simple words, this is a sort of an edge of our planet, the boundary between the place where we can breathe and the complete vacuum. Sunlight takes 1 or 2 electrons from the gases around the Earth, so these gases become charged particles. A huge accumulation of these floating particles creates the ionosphere. It's constantly changing its shape and size as the planet is rotating around its axis and sunlight's falling unevenly. During the day, the ionosphere is always larger than during the night. Because of this, it looks pulsating and moving in different directions. This instability shortens the life of orbiting satellites and often puts them out of action, but it also helps to provide communication. Radio signals and jeeps pass through it and reflect from charged particles and fly to our phones and navigation devices. Earth is not only glowing, but also pulsating. An unknown pulse is coming from the surface or the depths of the planet. The pulsation repeats every 26 seconds and never stops. At some point, it's similar to a human heart. It's working almost in the center of the chest. Earth's pulse comes from the planet's center, the equator, but the exact location of the source is unknown. In the 1960s, the pulse called microseism was discovered by seismologists in the US. More than 50 years have passed, and scientists around the world still don't know the nature of this phenomenon. It seems as if our planet has a heart hidden inside the crust. According to research, this heart may be located in the southern or equatorial part of the Atlantic Ocean in the Gulf of Guinea called the Bight of Bonny. Every winter, the pulse increases, but then its strength weakens again. Scientists began to explore this place and put forward the theory that the ocean creates the pulse. Waves cross the surface and hit the continental shelf of the planet. This impact deforms the ocean floor. A strike to any flat surface works on the same principle. Hit any plate with a hammer and you will feel a vibration through the object. The same beats are created by waves hitting the coastline. There are waves all over the world, not only at the equator. So why does microseism occur at the equator? Because in this place, the sun heats our planet the most. Solar energy increases storms and winds, accelerates ocean currents. Also, in 1980, geologists found out that microseism pulsates powerfully during storms when the waves hit the shore stronger. Not all scientists agree with this theory. Some researchers believe the planet is pulsating because of the seismic volcanic activity, and there's one that's located on one of the islands in the Bight of Bonny. The place of pulse origin is close to this volcano, but further observations have shown that microseism can be found in all places of the Gulf of Guinea. Scientists still can't prove any of the Hey look, some magical stuff is happening around you. Let's check out some real photos of overwhelming phenomena our Earth offers, and I'll chat about the science behind them. The rainbow-colored scarf cloud is a very rare natural phenomenon. World Meteorological Organization says that this kind of cloud is called pileus clouds. Here's how this rainbow scarf cloud takes shape. There are accessory clouds that depend on a larger cloud system in their development. An accessory cloud widens horizontally and gets shaped like a cap at the top. It attaches itself to the upper part of another cloud. These clouds don't last long, similar in time to a regular rainbow. The main cloud underneath eventually rises and absorbs the rainbow cloud. Who wants to see the ocean glowing and glittering like the sky full of stars? This phenomenon is called bioluminescence. When it happens, waves start sparkling neon blue, thanks to a natural chemical process. Living organisms, such as tiny crustaceans and algae, use bioluminescence to trick predators, attract prey, or find potential mates. Sparkling nightlights have been photographed across Australia and the Indian Ocean. This form of ice is called hair ice. It looks like cotton candy, but it melts away with the sun, not rain. Hair ice is a very unusual phenomenon, and it only forms under specific conditions. It grows on the surface of particular kinds of wood at temperatures below 30 degrees Fahrenheit. If the weather is calm and humid, the hairs can grow up to 8 inches long. In 2015, scientists discovered the fungus responsible for this smooth, silky ice hair. The presence of this fungus leads to a process called ice segregation. The fungus prevents ice crystals from gathering into more stable shapes. I mean, ice can still form on these branches when there's no fungus, but it would be shaped just like normal, not hair-like, ice. So what does this fungus do to make this magic happen? Due to the liquid near the surface of branches is in contact with chilly air. This creates a thin layer of ice. It blends a thin layer of water between the ice and the wood pores. This results in a suction force that pushes the water out of the pores toward the ice at the surface. It freezes there and adds to the existing ice layer. The process repeats over and over. Here you go. Thin hairs of ice are pushed out of the wood. Lake Baikal in Siberia is famous for its crystalline waters. It's the largest freshwater lake on the planet by volume. It contains 20% of Earth's fresh water. It's also very wide. To put it in perspective, it's larger than Belgium.
Plus, it's the oldest lake in the world, about 25 million years old.
And when it freezes during the winter, large shards of transparent ice form on its surface. They appear turquoise because the lake has clear waters. These gem-colored ice structures on the lake's surface are called hummocks. Hummocks are ice splinters. When fierce winds around the lake push its waters into waves, they freeze into these turquoise blocks. Hummocks can be 32 to 39 feet high. Take a look at Naga fireballs. This natural wonder occurs in a specific area around the Mekong River in China. They appear throughout the year, but they're more common during the full moon in late autumn. How they appear is a mystery. These fireballs seem to rise from the water. They can go as high as 985 feet. They are like fireworks, disappearing just as rapidly. They typically have a reddish or orange glow. Did you know that earthquakes emit light too? It turns out that earthquake lights have been around for centuries. They appear before, during, or immediately after an earthquake. They're generally white or blue. The lights rarely last for more than a few seconds, so it's hard to capture them on camera. Yet, on rare occasions, they can shine for up to 10 minutes. Sometimes, they are at the epicenter, while at other times, they're seen up to 250 miles away. They have been spotted over the ocean, too. Scientists know for sure that how powerful an earthquake is somehow influencing this phenomenon. The lights have only been reported during earthquakes rating 5.0 or more on the Richter scale. Scientists have some theories, but it's still a bit of a mystery why the lights exist in the first place. Moonbows have similar principles to rainbows. They occur when the light gets reflected off water droplets in the sky, yet they are much rarer than rainbows. They can appear only under certain conditions. When the moon is very low over the horizon, the sky is dark, and water droplets are in the part of the sky opposite the moon. Halos, also known as circle rainbows, are an optical phenomenon forming high in the sky when the light gets reflected off ice crystals. They look like large circles of white or colored light circling the sun or the moon. The next one is not as rare as the others just mentioned. A sinkhole forms in the ground as a result of some form of collapse of the surface layer. Most sinkholes are caused by the chemical dissolution of carbonate rocks. They're usually circular and vary in shape and size, both in diameter and depth, and you don't want to drive into one of those. A fire whirl is a whirlwind induced by fire. Most of the time, it's composed of flames or ash. This phenomenon is also sometimes called a fire tornado or fire twister. It's pretty clear how it got this nickname. It looks like a tornado and it's made of fire. Yet these terms usually refer to a separate thing, where a fire has such intensity that it creates an actual tornado. Fire whirls are different. They don't usually count as tornadoes as the vortex doesn't extend all the way from the ground to the cloud base. Lenticular clouds are usually in parallel alignment to the wind direction. They have a particular shape. I mean, look at it. That's what people imagine when they think about a spaceship of visitors from outer space. I'm at Wagjas and guess mean. Many people dream of witnessing this one. The Aurora Borealis or the famous Northern Lights. It's a free natural light show in the sky. Charged particles from the sun strike atoms in Earth's atmosphere. Then they cause electrons in these atoms to change to a higher energy state. Eventually, the electrons get back to a lower energy state. That's when they release photons of light. Obviously, Nordic countries are the best places to see this show. But hey, you can see the Northern Lights in Scotland too. The Morning Glory Cloud is a very long rolled cotton-like cloud. It's seen occasionally in various parts of the world. But there's one place on our planet where they occur on a regular basis. It's the Gulf of Carpentaria in northern Australia. These clouds can stretch for 620 miles. Plus, there can be more than one morning glory cloud at one time. So far, we have seen moonbows, halos, and many other phenomena. But how about looking at a fire rainbow? The fire rainbow is much easier to say, but the real name of this thing is a circumhorizontal arc. Say it with me. Circumhorizontal arc. Very good. It's another cool optical phenomenon that occurs in cirrostratus clouds. Check this out. The next two cool facts are related to animals. What would you do if 1,000,000 butterflies flew over your head? This might happen when you see monarch butterflies while they're migrating to Mexico or Southern California. These butterflies cannot cope with cold winters, nor can I. So every fall, they migrate either to the south or west, where it's warm all year long. This is a field completely covered with spider webs. This phenomenon only occurs when spiders flee from floods or some other kind of natural disaster. When they leave, they find a higher place to spin their webs. Usually, such a place is a tree or an agricultural field. Since many of them gather in the same safe region, they all make their webs at the same time. Doesn't this huge spider web look like a thick blanket? Yeah, you go lie down in that. Just kidding. Have you ever come across unique natural phenomena? Comment below and let me know. In the heart of the galaxy, there lies a mysterious object, the likes of which no astronomer has ever seen. It streaks across the sky like a shooting star on caffeine. So what is this mysterious blob? And how is it related to the black hole in the center of our galaxy? Let's find out. This thing is called X7. It's the mysterious blob that's been hanging around our galaxy's supermassive black hole for decades. Some even say it's been lurking around there for like hundreds of years. We know a few things about X7. For example, it weighs around 50 times as much as Earth. It may sound like a lot if you're an Earthling, but in space, that's like a tiny drop in the ocean. X7 is also moving pretty fast, at speeds of up to 700 miles per second. That's faster than you trying to catch the last slice of pizza before your roommate gets to it. But what in the world is this thing? A magic star we've never seen before? An extraterrestrial spaceship? Well, there are some theories connected to the blob's future tragic fate. Unfortunately, X7's days are numbered. Right now, it's on a 170-year-long elliptical orbit around the supermassive black hole at the center of the Milky Way, but it's not going to make it that far. Each year, it's spiraling closer and closer to the black hole. In just a few years, it will become spaghettified. Yes, that's a real scientific term, and finally get sucked in, never to be seen again. There are supermassive black holes in the centers of all galaxies, including our very own Milky Way. These black holes are so massive that they warp space-time, causing nearby stars to orbit around them at incredible speeds. They serve as cosmic vacuum cleaners that suck in anything and everything that comes close enough. The black hole in our galaxy is called the Sagittarius A star. Sounds like the name of a fancy Hollywood celebrity, doesn't it? But this celestial object is far more impressive than any mere mortal. It's about 4 million times more massive than our sun, which means it could probably eat our entire solar system for breakfast. But don't worry, these black holes may seem really scary, but in reality, they're too small to compete with an entire galaxy. They'll just suck in a couple of the nearest stars, and that's all. Also, Sagittarius A star doesn't seem to have a very good appetite. It's been observed to be pretty quiet lately, which is good news for us. But even if it were super greedy, it wouldn't pose any threat to us. This black hole is over 26,000 light years away. From Earth, we can see it in the Sagittarius constellation. In 2022, the Event Horizon Telescope collaboration released the first ever image of Sagittarius A star. It took years of collaboration and technology to capture this stunning image. And this is our second photo of a black hole in history. The first one was released in 2019, and it showed the supermassive black hole called M87 star. Yes, they both have star in their names. Don't try to make it make sense. Anyway, you may remember this photo as the first ever image of a black hole ever. It went crazy viral across the internet. And this black hole, M87 star, located in the Messier 87 galaxy, is way scarier than Sagittarius A star. You thought 4 million solar masses is impressive? Then how about 2.5 billion solar masses? M87 is a real monster. It's also known for its powerful jets of plasma, which are so energetic that they extend thousands of light years from the black hole's center. If M87 were a superhero, it would be Iron Man with his repulsor beams on full blast. Now, technically, you can't take a photo of a black hole itself, since it's, well, black. No light can escape its grasp. But the glowing orange ring in this photo shows the matter surrounding Sagittarius A star. It's called the accretion disk, a swirling disk of hot gas that spirals the center, heating up to millions of degrees in the process. It's like a giant fiery vortex, but with no escape. And the shadow in the center indicates the black hole itself. Inside that shadow, there's an event horizon. The event horizon is the boundary around the black hole beyond which nothing, not even light, can escape its gravitational pull. It's the point of no return, where the gravitational force is so strong that even the fastest object in the universe, light, can't escape. Once you cross the event horizon, you're doomed to fall towards the center of the black hole, where the laws of physics as we know them break down. And this is exactly the fate that awaits our unfortunate X7. Right now, the pure blob is getting stretched and yanked by powerful tidal forces. By the way, before it meets its untimely demise, X7 is expected to put on a bit of a show. Its closest approach to the black hole, called Periastron, is projected to happen in 2036. And when it finally gets torn apart by the Sagittarius A star's gravitational forces, there may be some cool fireworks to see. But this is not the most important thing. The funny part is, X7's future end may help us finally understand what the heck even is this thing. A team of scientists have been studying how a strange blob orbits the black hole, and that's when they discovered that X7 has stretched to almost twice its initial length. And what does that mean? Well, it suggests that X7 is most likely made of debris ejected during a recent collision between two stars. Yep, you heard that right, a space car crash. Imagine this. Two stars fall in love and start circling each other for many years. After that, they finally merge together. At this moment, they eject tons of gas and dust. And perhaps this cosmic dance created our blob baby, X7. It's basically like the crumbs left on the table after a giant space feast. Something like this is actually pretty common, especially around black holes. It's like a galactic fender bender that sends debris flying everywhere. Actually, the universe is full of mystery blobs. They're called the G-objects. No, they're not the G-men from Men in Black, but they're just as mysterious and elusive. These guys have been puzzling astronomers for more than 20 years. They look like gas clouds but behave like stars. It's like they can't decide whether they want to be a cloud or a star. Come on, guys, make up your mind. G-objects stretch out at the closest point to the central black hole, but emerge intact, like a rubber band that stretches but doesn't break. Scientists think that they're the stars that have merged together into one, and while doing that, they also produce a huge cloud of gas that hides the result from view. Kinda like when you're wearing a bulky sweater so that no one knows that you've put on a few extra pounds. And then a study published in 2021 found that one of these objects, G2, was actually a molecular cloud concealing 3 baby stars. Talk about a plot twist. But X7 is the black sheep of the strange blob family. It's significantly different from the G objects, like the weird cousin you see once a year at family gatherings. Its evolution has been more dramatic. Also, it's not being held together by a mass lurking in its center. So what is it being held together by? Pixie dust? Magic? We need answers. That's why scientists believe that X7 isn't a G object itself, but debris left from it. Or maybe not. We have no idea. The possibilities are endless, and that's what makes astronomy so exciting. So let's keep our eyes on the skies and see what other strange objects are out there. Who knows, maybe we'll discover another mystery blob, and this time it's going to be a spaceship. Now, that would be awesome. Did you know that there's an astronomical object in which space and time actually swap places? How does it work? And what exactly does swapping space and time mean? Well, let's figure it out. Imagine that you're on a spacecraft. The vehicle can only move straight. Your path leads to some inevitable point, and you have no idea what lies ahead. You can only hope that it won't be too bad. Meanwhile, everything around you is complete madness. A chaotic collage of many historical events. What do you see? Ancient humans and dinosaurs. The birth of the universe? Future? Who knows? That's what the universe would look like if we swapped time and space. And, theoretically, this is what you'd see if you fell into a black hole and somehow were able to survive. But how is something like this even possible? First of all, let's discuss time and space. Imagine drawing a light bulb on a sheet of paper. Then grab one more sheet and draw how it lit up. Right now, it's just a small circle of light. Another sheet. the circle of light is growing. It gets bigger and bigger in size until finally it turns into a huge circle. In real life, the bulb lights up in the blink of an eye. That's because the speed of light is the fastest in the universe. But here, on our drawings, we captured the propagation of light frame by frame. We see how over time the light has grown from a small dot to a large circle. But if you connect these circles, doesn't it remind you of some shape? For example, a cone? Yes, exactly. This is called a light cone. And time is the central axis of this cone. Why? Because light turns from a small dot into a large circle over time. To remember it, let's draw a time vector, an arrow inside the cone. It goes from the past to the future. Meanwhile, the circles are space. In space, we can move however we want, in any direction. We can move up or down, in zigzags, and so on. But no matter what zigzags we draw along the timeline, we're always moving forward. We can't turn back time, and we can't stop it. This helps us define time and space. Time is the direction in which the light cone is oriented. This is the direction where all our paths lead and where our future inevitably lies. And space is the whole variety of directions perpendicular to the timeline. This is a straightforward graph. If it could be applied to the entire universe, then time would flow the same everywhere. However, if you've watched at least some popular sci-fi movies, you know that this isn't the case. In reality, time can be crazy. For example, if you're chilling near a black hole, what will be 2 hours for you may turn out to be 20 years for your friend on Earth. But why? Take a deep breath. Now, gravity comes into play. Oh, I know about gravity. It's that thing that helps me to stand on the ground, you may think. But it's much, much more complicated than that. Gravity is one of the basic physical forces in our world, and it's incredibly powerful. In fact, she's such a girl boss that she can distort space and time. She literally can influence the speed of time like an almighty wizard. How? Well, let's take something slightly bigger than a light bulb. For example, a supernova. Somewhere in the universe, a star has just made a boom. How do we know about it? Well, nothing in the universe, no sound, no radio waves, nothing travels faster than light. So we'll know about the birth of a supernova only when we see it. And this will happen only when its light cone grows enough and reaches our planet. So the light cone grows and grows. So far, everything is fine. And finally, it reaches our planet. But there's a catch. You see, our planet is massive. Very massive, and it has pretty strong gravity. What happens then? Gravity changes the direction of the light cone. It begins to attract the cone to the center of our planet, and with it, it also attracts our arrow of time. That means it slows the time down, and the closer the light cone is to us, the more the arrow bends, and the slower time goes. What does it mean? For example, the fact that the watch on your ankle will lag behind the watch on your wrist, that your head is aging faster than your legs, and that astronauts in Earth's orbit age a little slower than people on Earth. This is what scientists call general relativity, right? But how does this relate to our topic? How can we understand what will happen if we swap space and time? Don't worry, we're almost there. Now imagine a cosmic body with incredibly strong gravity. It bends time and space so much that it feels like they swap. This is a black hole. A black hole attracts absolutely everything to its center. No stars, planets, no light can escape from there. Let's say our light cone is approaching it. First, as usual, time begins to bend towards the center of the black hole, attracted by its gravity. But the gravity is very strong, so it bends more and more, and time goes slower and slower the closer you're to the center. In the end, the light cone crosses the boundary of the black hole, the so-called event horizon. At this point, it got so distorted that now it's literally pointing downwards. We can say that time has changed its direction. Time is pointing downwards? What kind of nonsense is that, you may ask? It will be easier to explain in a real example. Imagine you're a crazy astronaut who decided to jump into a black hole, and there's an observer in a spaceship who watches you doing this for some some reason. At first for you, nothing changes. You look at your watch, you see that 5 minutes have passed, and everything is okay. But for the observer, first of all, you'll fall for a very long time. The observer has been sitting there for 50 years, and you're still falling. All because your time has slowed down. Secondly, since space is also distorted near the black hole, the observer will see how you'll begin to stretch like spaghetti. This is a scientific term, by the way. It's called spaghettification. And then, you finally cross the event horizon. The observer doesn't see you anymore. Light cannot escape from a black hole, so your image won't reach the observer, even if you're still inside. And what about you? What if you somehow survived? Remember, the time arrow is pointing to the center of the black hole. What does it mean? It means that now, the center of the black hole is your future. It isn't a place. It's a fate that you can't change. And wherever you came from, as well as the rest of the universe, no longer exists for you. Because now it's not a place, but an event from the past. And since you can't turn back time, you'll never be able to come back. But what is around you? Complete chaos. The rays of light now move in all directions, forward, backward, and so on. The rays depicting the events of the past, the future, the present, all this is moving around you. In reality, space and time didn't swap places, but it feels like they did, because in space, you can now only move forward as if along a straight line, and time, reflected in the light rays, surrounds you everywhere and moves in all possible directions. And here we go back to the beginning. This horrifying example helps us imagine what it would feel like if time and space got reversed. Of course, all this is just theories and guesses. The very idea that we're moving in some one direction, the one we haven't chosen, and there's complete time chaos around, sounds quite frightening. And yet, it would be a very interesting experience. Sounds dangerous. You go first. Jupiter used to be flat and look like an M&M candy. And it wasn't the only flat planet in our solar system. Turns out there are tons of things that can go wrong during a planet's formation, like locking up to the sun or getting whooshed in open space. Let's check it out. The Earth isn't flat, but Jupiter might have been. Instead of being a big round ball, gas giants in our system might have started more like flat pancakes. Jupiter is one of the oldest of our neighbors. It's 4.6 billion years old, just like our Sun, and when it was just a baby planet, it likely formed through a process called disk instability. On 3 sec pause. It all begins with stars. When a star is forming, it doesn't look like a round object. It's more like a big disk of stuff. During this stage, really hot winds made of charged particles blow out. The dust in that disk contains stuff like carbon and iron. Some of them collide and stick together, forming bigger objects. Dust turns into pebbles, pebbles turn into rocks, and rocks bump into each other, getting bigger. Gas in the disk helps all these solid bits stick together. Some break apart, but others stick around, and they're the ones that become the basic pieces of planets. They're called planetesimals. Even gas giants like Jupiter started off as tiny specks of dust smaller than a human hair. Eventually, they formed their own big, ring-shaped disks of gas. They began to spin around our sun, growing bigger by gathering gas and rocks like snowballs. To 2-3 sec pause. Gas giants are special. They were born from the colder parts of the disk. In cold areas, molecules are slower, which makes them easier to grab. In these places, water could freeze, and tiny ice pieces stick together and are mixed with dust. These dirty snowballs gather up and then form cores of huge planets like Jupiter, Saturn, Uranus, and Neptune. In the warmer areas closer to the star, rocky planets like Mercury, Venus, Earth, and Mars start to form. After the icy giants were born, there wasn't much gas left for these smaller planets. It might take tens of millions of years for these rocky planets to form after the star is born. And our sun was growing at the same time, sucking up nearby gas and pushing faraway stuff even farther out. After billions of years, the disk changed completely. turning into a round star with a bunch of planets, dwarf planets, asteroids, moons, meteoroids, and comets around it. A thirdly, 3-sec pause. Recently, simulations showed that these protoplanets, as these early dusty balls are called, don't start off looking like the planets we know. In the case of gas giants like Jupiter, they looked more like squashed balls or M&M's candies, not the peanut kind. When the sun was young, the disk of gas and dust surrounding it cooled down and became unstable. It started breaking into big chunks. These chunks dramatically collapsed together under huge gravity to create Jupiter. It became a round gas giant over time. There are a lot of oddities that can happen during that process of planet formation. Ever wonder why Venus or Uranus spin the opposite way compared to other planets? Usually, when things form from a spinning disk of gas, they tend to spin in the same direction. For example, if you spin a bunch of balls on a string, they'll all twirl in the same way. So, theoretically, all planets should spin in the same direction too. But there are a lot of fast-moving objects, like comets and asteroids in our solar system. When they smash into planets, especially during their early days, this collision might send the planets to spin in the opposite direction. Venus and Uranus probably survived a massive collision. Luckily, they weren't repelled to outer space. The gravity from the sun and nearby planets pulled them back into place. 4-3-sec pause. There are also so-called tidally locked planets. These are celestial bodies that spin in a way where one side always faces their star while the other side remains in perpetual darkness. So, one side is always very hot while the other is extremely cold. If we were on a planet like that, we would only be able to live on a thin line in between. These planets form when they're very close to their star. The gravitational forces are extremely strong, and over time, these forces slow down the planet's rotation until it matches the time it takes to orbit the star. Imagine you're spinning in your chair. Someone comes up to you and, holding onto your chair with their hands, starts spinning with you. This way, you'll always face each other. Tidally locked planets kind of worked like that. Our moon is tidally locked to our Earth, which is why we only see one side of it. Suffer 5, 3-sec pause. We discovered more than 5,000 planets outside of our solar system, called exoplanets. Some of them have very strange orbits. For example, planets with incredibly long orbits, thousands of years to make one trip around the star, or very wonky, comet-like orbits. Or so-called hot Jupiters, they're super close to their star, way closer than Mercury is to our sun. But these planets couldn't have formed where they are now. As their solar system evolved, they changed their positions for some reason. This rearranging is called planetary migration. 6 3-sec pause. There are 3 main ways this migration happens. First, because of the gas and dust spinning around the planet. When a planet is bumping into this stuff, it can create spiral patterns in the gas. These patterns can either push the planet closer to the center or farther away, depending on how they mix together. It's called a gas-driven migration. This is what Jupiter experienced when it moved closer to the sun billions of years ago. This also explains the existence of hot Jupiters. Second, big planets can shove the smaller ones, changing their paths. Third, the star's gravity can tug on the planet, making its orbit more circular. S7 3-sec pause. Ever heard of rogue planets? Imagine a lonely planet floating in the vastness of space without a star to call home. They're like the wandering nomads of our galaxy, doomed to drift around forever. And there are so many of them. There might be more free-floating planets than ones that are tied to stars. We're talking trillions of rogue planets hanging out in our Milky Way galaxy alone. They're often as massive as our biggest planet, Jupiter, but most of them might be Earth-sized. Some might even have thick atmospheres that keep them warm. Even though they're far from any star, some of them might have wild auroras, while others could host moons with liquid water. Ait Satsam, from what Metro Seminole comes to sight. I might persistent sites. For Shmai, there's even a chance that they might contain extraterrestrial life. These planets might bump into other stars or even entire planetary systems as they journey through space. Sometimes, they might get caught in a star's gravity for a while before getting flung back out into space. But how are they born? Sometimes, during this chaotic process of planet formation, not all planets can manage to stay close to their parent stars. Some of them get kicked out of their solar systems due to powerful gravitational interactions with other planets or passing stars. These ejected planets become rogue planets. This 3 sec pause. In 2012, astronomers found a solar system from the very beginning of the universe. This system included a star and 2 planets. We called it a fossil system. The star is super old, about 13 billion years, almost as old as our entire universe. It was mostly made of just hydrogen and helium. Hundreds of millions of rocks orbit the Sun within the asteroid belt between Mars and Jupiter, but only some of them come relatively close to Earth. NASA classifies asteroids orbiting within 48 million kilometers of our planet as near-Earth objects, NEOs. And inside this group, there are particularly worrisome objects. Those are so large and orbit so closely to our home planet that they could turn into a real threat to the world should a direct collision occur. At the moment, NASA is keeping a close eye on an asteroid named Bennu. It's a fairly large space object, 610 FT across, that might smash into our planet in 159 years. According to experts, the asteroid, which was first spotted in 1999, is quite likely to drift into the orbit of our planet. If it happens, it might collide with Earth by the 24th of September, 2182. Asteroid Bennu is thought to be taller than the Empire State Building. If it hits our planet, the collision will release 1,200 megatons of energy. That's an enormous amount of energy that nothing built on Earth could produce. Scientists from NASA believe that, during the flyby in the 22nd century, there is a tiny chance that the asteroid will pass through a gravitational keyhole. That's a region of space that might set the space traveler on a certain path, which could result in the asteroid crashing into Earth. Bennu flies by our planet every 6 years. It has had 3 close encounters with Earth, in 1999, 2005, and 2011. These days, scientists estimate the chance of the asteroid hitting our planet by 2182 as 1 in 2,700. That's more than 5 times a person's chance of being struck by lightning. But even though Bennu's chances of colliding with Earth are quite low at the moment, the space rock has still been categorized as a potentially hazardous asteroid, all because it might come as close as 7.5 million kilometers from Earth. That's the reason why it's also classified as a near-Earth object. Bennu is a carbon-rich asteroid that formed in the first 10 million years of the history of the solar system. That's around 4.5 billion years ago. No wonder this space body holds precious clues to the origin and development of the rocky planets of our solar system, which are Mercury, Venus, Earth, and Mars. Even better, it may contain organic molecules similar to those that are crucial for life to evolve. In 2020, NASA's OSIRIS-REx, Origins, Spectral Interpretation, Resource Identification, and Security Regolith Explorer managed to briefly touch the surface of the asteroid. It collected some sample space rock afterward. For NASA, it was the first mission of this kind, but it won't probably come as a surprise that Bennu isn't the only asteroid we should worry about. Asteroid 99942 is another space body we'd better watch out for. It's a near-Earth object about 335 meters across. It was discovered in 2004, and at first, it was identified as one of the most dangerous asteroids ever detected. Apophis gained notoriety very fast. It was believed to pose a serious threat to Earth. Experts predicted that it would come uncomfortably close to our planet in 2029. Luckily, after a more careful examination of Apophis and its orbit, astronomers concluded that there was no risk of the asteroid colliding with our planet for at least a century. The risk of an impact in 2029 was ruled out completely, as well as the potential impact that could be caused by the asteroid's close approach in 2036. Interestingly, until March 2021, there was still a small chance of a collision in 2068. But then, Apophis made a flyby of Earth, and astronomers took this chance to use powerful radars to estimate the asteroid's orbit around the Sun more precisely. This allowed them to rule out any impact risk for at least the next 100 years. Now, the reason why such discoveries make us so worried is that even a relatively small asteroid, the size of a house, can wreak havoc upon colliding with our planet. And if an asteroid is larger than 1 kilometer across, astronomers call it a planet destroyer. The impact energy released by such an asteroid after striking Earth could be devastating. That's why knowing where such asteroids are and in what direction they are moving is crucial. The problem is that our capability to protect the planet from asteroid impacts is not top-notch yet. If such a catastrophe was about to occur, we would need pretty much time to prepare, because an asteroid collision is no joke. Probably the most well-known asteroid impact site is the Chicxulub crater. It's the evidence of the terrifying collision that led to the extinction of dinosaurs. Strangely, this crater isn't very visible, but some others are. For example, Barringer Crater in Arizona, which is also called Meteor Crater. It looks rather blood-chilling when you think about the collision that led to its appearance. In any case, we now know that space rocks hit not only Earth, but also the Moon, Mercury, and Mars. No rocky planet in the solar system is safe from asteroid impacts. That's why we have an entire scientific enterprise whose goal is to find and catalog the asteroid population of the solar system. It might sound a bit scary, but there are around 25,000 asteroids larger than 140 meters in diameter near the orbit of our planet. Such a space rock is large enough to wipe an entire city off the face of the Earth. So far, less than 50% of such asteroids have been detected and tracked. There are also an estimated 230,000 objects equal to or larger than 49 meters in size. Those are capable of destroying a concentrated urban area. And still, fewer than 8% of those have been detected. There are also tens of millions of smaller, near-Earth objects. They are larger than 10 meters across and might cause some surface damage. Less than 1% of such small space bodies have been discovered so far. The thing is, the inner solar system is extremely challenging for asteroid search. Each night, there are only 2 10-minute windows when astronomers can observe the region, all because the sun's glare creates a very bright background glow. Plus, the atmosphere of our planet also distorts and blurs observations. Spotting asteroids in such conditions is beyond the capabilities of most telescopes. A really unique instrument is needed to fulfill this task, and the tool of choice is the Dark Energy Camera, DEC, at Cerro Tololo Inter-American Observatory in Chile. This device wasn't designed to hunt asteroids. Researchers built it to search for another elusive target, dark energy, the mysterious force driving the expansion of the universe. The DEC is supposed to observe hundreds of millions of galaxies. That's why it's both wide and deep. This way, it can both peer deep into the universe and capture a wide field of view, which helps it record the motions of galaxies and the conditions in the early age of the universe. But it also means that the DEC is perfectly suited to spotting asteroids near the Sun. Inner asteroids are rare, and deep images are necessary because such asteroids are faint. Scientists need to be able to fight both the bright twilight sky near our star and the distorting effect of Earth's atmosphere. And the DEC can help them achieve their goal. The Dark Energy Camera was built to carry out the Dark Energy Survey, which finished in 2019. Now, astronomers can direct the power of the camera toward other tasks. They claim that the DEC survey is one of the most sensitive searches ever performed for objects near Venus's orbit and within the orbit of our planet. It provides us a great chance to find out what kinds of objects are lurking in the inner solar system. We also might have just stumbled upon the mother of all water reserves, floating in space, and it's been hiding under our noses for at least around 12 billion years. As for its size, it's hard even to imagine. 140 trillion times larger than all the oceans on our home planet combined. This cosmic water world is orbiting around a large black hole known as a quasar, located 12 billion light-years away. Quasars feature supermassive black holes, spewing out colossal quantities of radiation. This one in particular is estimated to be 20 billion times heavier than our Sun, and carrying energy that could outshine 1,000 trillion of them. Here, in our cozy Milky Way, we're used to seeing water in ice form. This water reserve in particular seems to be in the shape of vapors. The important thing about this discovery is that there may be water everywhere in the universe. We just need to learn where to look. You might be surprised to learn that not all stars are hot to the touch. We used to think all stars were like our Sun, these blazing hot balls of fire, ready to melt anything in their path. Their cooler counterparts are called brown dwarfs. What makes them special is that they're too small to pull off the nuclear fusion that keeps stars like our Sun shining. They don't give off much light or heat, which makes them hard to see. These brown dwarfs are also split into different categories. There's this one group called Y-type stars, and they're the coldest, with a surface temperature lower than your average cup of tea. If you could reach out and touch one, you'd probably just feel a cozy warmth. Around 4 billion years ago, Uranus apparently switched places with Neptune. It's hard to imagine planets that big doing that, but this theory might solve the mystery of how our solar system came to be. We know that rocky planets formed after big collisions. Take our planet, for instance. Around 4.6 billion years ago, things kept bumping into each other around the Sun until our watery Earth reached its final form. It also included one larger collision that blew up enough rock and gas for it to generate our moon. But when it comes to our larger solar system neighbors, Jupiter, Uranus, and Neptune, scientists still haven't got an answer. Standard models said it'd take forever for them to form, way longer than the solar system itself has been around. If this new theory is correct, it suggests that Uranus and Neptune came from this dense cloud of gas compacted around the Sun. Problem is, for the theory to make sense, they had to have swapped places at some point in history. Neptune is about 2.13 billion kilometers away, the farthest any planet can be in our solar system. Uranus is a bit closer, located at 3.5 billion kilometers. This new idea suggests that after they formed way closer to the Sun than they are today, their positions were altered. It could have either been because of many comets passing by over billions of years, slowly tugging the giant planets away. It's not a definitive answer to how gas giants were formed. It's more like a strong hunch, backed up by looking at a lot of numbers. Speaking of weird things found in our universe, what about this floating spoon that NASA's Curiosity rover took a picture of on Mars? As the machine was cruising around the red planet, it stumbled upon this oddly spoon-shaped rock during the summer of 2015. The rock has a handle and even throws shade on the ground. It's not a leftover utensil from some Martian picnic, but rather what NASA scientists call a ventifact. That means it's a rock that got sculpted by the wind. It's not the first time the Martian surface has delighted us with weird, windy sculptures. There was the face on Mars, a rat, and even jelly donuts. It's also possible that diamonds are raining down on over 1,900 exoplanets out there in space. Scientists found out that you don't need particularly hot temperatures for carbon to turn into diamonds, like it was previously believed. Up until recently, we only knew of Neptune and Uranus to potentially feature sparkling showers. Astronomers were onto this interesting phenomenon for about 4 decades, but these planets were hard to study. We've only had one space mission, Voyager 2, swing by for a peek. A lot of progress is being made, though, thanks to lab simulations. Neptune and Uranus are called the ice giants because their outer layers are filled with hydrogen, helium, water, and ammonia, what scientists call ice. And that gorgeous blue hue they have is due to the methane in their atmospheres. The beautiful diamondy phenomenon happens deep down, however. If we could visit, we would see that beneath the thick atmosphere, there are layers of very dense ice. And under all that pressure, chemical reactions are happening, possibly generating diamonds the size of a small town. We can't just dive into Neptune or Uranus with a diamond-seeking probe. Instead, the same conditions are being replicated in labs here on Earth, squeezing matter between diamond anvils and zapping it with lasers to mimic the extreme conditions. Under these circumstances, scientists managed to create artificial diamonds. Understanding how these rocks form down there could also explain why Neptune is hotter than it should be and why it's got such intense storms. These diamonds might also be the key to unlocking the mystery of Uranus and Neptune's weird magnetic fields. If we compare it to our planets, it doesn't behave the same way, so there may be weird things happening under the surface to affect the magnetism. NASA's plans include sending a new probe to Neptune or Uranus in the next decade. With the planets aligning just right in 2030, it's the perfect time to explore these potentially diamond-filled worlds up close. Planet Kepler 78b is another weird cosmic discovery. It's a hot, molten world that's doing laps around its star in record time, once every 8.5 hours, and pretty close, less than 1.6 million kilometers away. Hot environment aside, if we could set foot on its surface, we'd notice its sun being 80 times larger on its sky than the daily view we have here on Earth from our star. If we apply what we know so far about how planets form, this little guy shouldn't even be there. Specialists still don't have a clue how it came to be, or how it ended up where it is now. What we do know is that it will disappear soon. Sort of. Since it's so close to its start, this scorching, hot planet is going to collide with it in a couple of billion years. Sounds like a lot, but it's a cosmic jiffy. What's similar between our planet and Kepler 78b is the density. Sure, it's about 20% bigger than Earth and weighs almost double, but it's got that same solid interior. There's no possibility of it forming any closer to its star and simply moving away with time. It also couldn't have been born much further away and migrated in. Any movements inward would have been unstoppable, and it would have also collided with the star. This may not be a particularly groundbreaking discovery, but chances are you've never thought of it. There may be space dust in your hair right now. Every day, loads of outer space matter comes raining down on Earth. Sometimes we get flashy objects, like when a meteor turns into a meteorite by crashing down to the ground. But most of the time, it's quieter. This cosmic material drifts down through the atmosphere, landing softly as what we call space dust. It may not sound like much, but it does add up to around 14 tons every single day. This space dust contains tiny fragments of rock and metal, broken off from asteroids and comets during big collisions. These particles are very small. You can't see them without special tools, but every time you step outside, some of it might land in your hair. This year before September, a star in the constellation of Corona Borealis will explode, and in the northern hemisphere, we'll be able to see it with the unaided eye. This star is T Coronae Borealis, a white dwarf star 3,000 light-years away from our solar system. It will turn into a nova, which we'll discuss a bit later, in spring or summer. Even though this occurrence is predictable, happening every 80 years, it's still a once-in-a-lifetime event if you're a human. T Coronae Borealis is not your regular star. It's actually a binary, two stars orbiting each other. This pair, though, is incredibly special. Occasionally, the stars increase their brightness to such an extent that they become visible on Earth. The white dwarf star is the more massive one of the two, but the most shocking thing about it is that it might pack the same mass as the Sun into a volume only as large as Earth. The companion star, an aging red giant, has already expanded so much that it's dumping its material onto the white dwarf. So, it's time for another explosion for these two. It's going to take the star's brightness from magnitude 11 to magnitude 2. In astronomy, magnitude is used to measure the brightness of a star or another celestial object. The brighter it is, the lower the number assigned as a magnitude is. In our case, it means that we'll be able to see the star with the unaided eye, even in light-polluted skies. Now we can only see the binary with binoculars in a completely dark sky. After the outburst, T Coronae Borealis will remain the brightest star in the constellation of Corona Borealis for a few days before gradually dimming. This event shouldn't be confused with a supernova. In a supernova, a star's core collapses, which leads to its complete destruction. It can only happen to a star 8 times the mass of the Sun. Instead of disappearing in a blinding flash of light forever, T Coronae Borealis will experience a nova, an explosion on its surface, flinging matter into space but not ruining the star itself. Such recurrent novas happen at regular intervals. T Coronae Borealis was known to astronomers of the past as the Blaze Star. Last time, it exploded in 1866 and 1946. Astronomers from NASA believe that it's going to do it again before September this year. The constellation of Corona Borealis, also known as the Northern Crown, is one of the most beautiful out there. It's a curved semicircle of 7 stars, which is easy to find in April. You should go outside 2 hours after dark and look to the east-northeast. Once you find the Big Dipper, use the curve of its handle to go arc to Arcturus, finding the bright star in the Boötis constellation due east. If you go diagonally down to the east-northeast horizon, you'll spot Corona Borealis. If you want to observe the brightening of T Coronae Borealis, it might be better if you get acquainted with the region and the stars of the constellation it's in. Once the event begins, you will be able to compare its brightness against the other stars and observe the thing without using any fancy cameras. A nova is a short-lived, sudden explosion, involving a compact star as large as Earth or a bit bigger. The outburst comes from a white dwarf circling remarkably close to a regular star, so close that a stream of gas flows between them. This gas starts piling up until it creates a layer on the white dwarf's surface, and then it reaches a point where it detonates in a runaway thermonuclear explosion. According to astronomers, around 50 novae happen each year in our galaxy, but not all of them are noticed. NASA's Fermi Gamma Ray Space Telescope has observed several novae that occurred not far, on the scale of the universe. They found out that each blast produces gamma rays. Those are the most energetic forms of light. Researchers also think that these gamma rays result from collisions among numerous shock waves racing from the explosion site in a quickly expanding shell of debris. Now, after we've talked about novae, it's time to discuss something much more dramatic: supernovae. It's the largest explosion humans have ever seen. Each blast is a super powerful burst of a star. One kind of supernova is caused by the last hurrah of an extinguishing massive star. It happens to stars at least 5 times the mass of our Sun. Once they near the end of their lives, they go out with a ginormous bang. Huge stars burn incredible amounts of nuclear fuel at their cores, producing tons of energy. It makes their centers immensely hot. Heat generates pressure, and this pressure keeps such stars from collapsing. But any star is in balance between 2 opposite forces. Its gravity attempts to squeeze the star into a tiny, tight ball, and the nuclear fuel, burning in the core of the star, produces powerful outward pressure. Now, when a giant star is running out of fuel, it starts cooling off, its pressure drops, and gravity wins. The star collapses. An enormous object that is millions of times the mass of Earth collapses within 15 seconds. No wonder this brisk process produces enormous shock waves. It makes the outer layers of the star explode. Eventually, an incredibly dense core is all that is left behind, besides a growing cloud of hot gas called a nebula. A black hole, the densest object in the universe, is the result of a supernova of a star around 10 times as massive as our Sun. There's another type of supernova, It usually happens in systems where two stars orbit each other, and at least one of these stars is a white dwarf the size of our planet. If such a star collides with another or pulls too much matter from its neighbor, it can explode into a supernova. Also, supernovae are often so bright they can outshine the combined light of entire galaxies for several days, or even months. Supernovae aren't common. Astronomers think just a few of them occur within a century in galaxies like our home Milky Way. But since the universe contains an enormous number of galaxies, we can observe a few hundred supernovae every year outside our galaxy. Unfortunately, space dust blocks our view of most supernovae happening within the Milky Way. Betelgeuse, a late-stage red giant, exploded in 2019, but it wasn't the event we expected to see. This star is found in the constellation of Orion and is huge, so big that if we moved it to the middle of our solar system, its outer edge would go way beyond the orbit of Jupiter. When Betelgeuse eventually nears its end, it will explode in a stunningly bright supernova visible on Earth even during the day. This explosion could happen as soon as tomorrow or as far-flung as hundreds of thousands of years from now, so don't hold your breath. But then, what was it in 2019? Astronomers noticed that the star was dimming. They decided it was the initial stages of the grand show, but instead, Betelgeuse went back to normal over the course of the next few months. Further analysis revealed that the star hadn't dimmed. It just looked like that because we had been observing it through a cloud of stellar debris. At the same time, the amount of light in the photosphere of Betelgeuse ramped up. It was like a massive explosion of material from the surface of the star. Events like this occur on the sun all the time, especially when our star's activity is high. Bits of the sun's surface get tangled up and cast off. That's what we call coronal mass ejections. They do not harm our planet, but they can mess with satellites and electrical equipment. Getting back to Betelgeuse, we've never seen such a huge mass ejection of the surface of a star before. It's a new phenomenon, which we can observe directly and even see surface details with the help of the Hubble telescope. Astronomers say we're watching stellar evolution as it happens for the first time. There's this mysterious thing in space, an unusual spot that scientists haven't been able to explain for more than 15 years. There are different theories, and one of them says that maybe this is an imprint from a collision with a parallel universe. Is this true? Well, let's see. Take a look at this map. This is the map of our universe. Well, not really. This is actually the map of cosmic microwave background radiation, or simply CMB. Many, many billions of years ago, there was a Big Bang. It was so powerful that it created our entire universe. And of course, such an event couldn't occur without leaving some consequences. And these consequences are literally everywhere. The Big Bang left electromagnetic radiation, which we know as CMB. We don't notice it in our daily lives, but it's literally here, under our noses. And if you had some kind of superhuman vision, you would see how everything around you shines with this dim light. This radiation is very important. If we hadn't discovered the CMB, we would have never found out about the Big Bang. Previously, scientists believed that the universe had always existed. There was no beginning and there won't be an end. It sounds pretty ridiculous to us now, but less than a century ago, people were absolutely sure of it. Stephen Hawking was one of the first scientists to guess that the universe did, in fact, have a beginning. The guy was so cool that he realized this as a student while working on his doctoral dissertation. But, unfortunately, he had no proof. If there was such a strong bang billions of years ago, then where are the traces? Where's the proof? Laughed people who believed in the eternal static universe theory. But don't worry, they had the proof rubbed in their faces real soon. In 1965, astronomers Arno Penzias and Robert Wilson discovered CMB, and that was the first grandiose proof of the Big Bang. It turned out that radiation was everywhere. We just didn't notice it. In fact, at first, Penzias and Wilson themselves mistook it for the noise of a big city, or pigeons, or something else. For their discovery, which turned the world of science upside down, they received the Nobel Prize. Alright, so people learned that they were surrounded by electromagnetic radiation. Then, they started collecting more data about it. They accumulated more and more info over the years until they made this very map. This is a map of CMB temperatures. But while creating it, scientists discovered something unusual. Let's take a look at this map. It looks like a large and diverse pattern of cold and warm places. But in reality, our universe is quite uniform. All temperatures on this map are close to 455 degrees with very little difference. All temperature fluctuations between these places are small, and each tiny speck actually spreads over millions of light years. So everything in our world is pretty calm and stable, except for one point. This cold spot right here. Astronomers first discovered it in 2004. First, it looked like nothing unusual. It's just a region where the temperature is below average for a couple of microkelvins. But remember, we're not talking about a small area. This is a giant cold region. It's literally billions of light years in size. Wait, the scientists thought, this can't be true. The universe should be consistent everywhere. According to our standard model, this cold spot simply shouldn't exist. But it does exist though. This isn't just some mathematical error, it's right there. So, what is this cold spot and how did it appear? Astronomers have been trying to find the answers to these questions for years. Even now, we have only a few theories. So let's discuss them all. Theory 1, cosmic texture. This idea was brought up at the end of 2007. Then, scientists suggested that this cold spot could be the hills of space. In other words, it may be a bumpy region of the universe, just part of its texture. But that's a silly explanation, so this theory was quickly discarded. Theory 2, the supervoid. This hypothesis was considered the most plausible for a while. It stated that the cold spot was actually the so-called supervoid. It's a terrifying, dark place of our universe with almost no galaxies. And because it's an empty region with almost no stuff in there, it seems cold to us. However, this theory was refuted in May 2017. After carefully examining the cold spot, scientists found out that there were no signs of a supervoid there. Moreover, voids and supervoids, which actually exist by the way, are still very small in size. The cold spot is literally thousands of times bigger than them, so there must be some other explanation. And there is one. Perhaps the most bizarre of them all. Theory 3, a parallel universe. This controversial idea was put forward by cosmologist and theoretical physicist Laura Mersini-Houghton. She suggested that the cold spot could be an imprint from the collision of our universe with a parallel one. Standard cosmology cannot explain such a giant cosmic hole, says Mersini-Houghton. This is the unmistakable imprint of another universe beyond the edge of our own. Her assumption is based on the theory of the multiverse. This theory says that there's actually an infinite number of universes like ours in the world. They constantly collide with each other, giving each other a push, which creates a new Big Bang. So maybe the cold spot is a bruise from such a collision? For quantum mechanics, such crazy theories are pretty common. But for standard physics and our simple understanding of the world, this is earth-shattering. Of course, we need strong evidence. And Mersini-Houghton's team has begun to work on it. Professor Tom Shanks from the Center for Extragalactic Astronomy at Durham University also participates in this research. The craziest sounding of the exotic models for the explanation of the cold spot, the multiverse is actually the most standard in terms of our current model of the universe, he wrote in one of his works. So, what evidence do we need? Well, our cold spot is located in the southern hemisphere. According to Shanks, if there really was a collision between two universes, we should find another cold spot and it should be in the opposite northern hemisphere. If astronomers actually found it, this theory would be confirmed, and it had become the first proof of the existence of a parallel universe. But it's not that easy. To find a second spot, we need the latest, highly sensitive telescopes. We also need to find out some info about the nature of dark energy, how it affects space, and, in other words, there's still a lot of work to do. Not so long ago, scientists actually believed they had discovered the second spot. Researchers from New Mexico thought they had found it in the northern hemisphere. But unfortunately, this is likely to be a mistake. The map these researchers used had a high measure of randomness, so it's possible that their discovery is just an accident caused by other voids. So basically, we haven't found another cold spot so far despite careful analyses. But again, even the best modern equipment is not perfect, and it doesn't mean that there's no second spot. It just means that we haven't found it yet. But if one day we did find it, it could change the world of science forever. We'd confirm not only the theory of parallel universes, but also the famous string theory, and it could explain everything that occurs in our world. But if this happens, we'll get even more questions than we already have. How did these two universes collide? How does it all work? So far, it's all just guesswork. We can't claim that the cold spot is a print from the collision of parallel universes, but we can't refute this either. Actually, we may never know the truth at all, but it's still interesting to strive for it. Jupiter is the largest planet in the solar system. More than 1,300 Earths could fit inside this gas giant. It's also 2.5 times more massive than all the other planets of the solar system combined. But if you think this is mind-boggling, I've got some great news for you. Very recently, a team of astronomers has discovered a much bigger planet with the help of the Subaru telescope and the NASA Hubble Space Telescope. It's a Jupiter-like protoplanet orbiting a very young star called AB Aurigae. The star is probably still forming and is no more than 5 million years old. For comparison, our Sun is 4.6 billion years old. The young star is located around 531 light-years away from Earth, in the constellation of Auriga. The star is shrouded in a thick, quickly moving layer of gas and dust. This disk feeds the growth of the star. Later, what is left of this disk will come together to form the elements of the planetary system. Planets, dwarf planets, comets, asteroids, you name it. But back to the newly discovered planet. It's a gas giant whose mass equals that of 9 Jupiters. Can you imagine this colossus? It takes the planet, named AB Aurigae b, almost 588 Earth years to complete just one journey around its parent star. Maybe because it's 93.9 AU, astronomical units, away from it. Now, why is the discovery of this planet so amazing? Because according to astronomers, it's been forming in a very bizarre way. Or should I say, eyes forming, since this gas giant is still in the process. Anyway, the unusual thing is that AB Aurigae b is coming together as a result of a top-down gravitational collapse of giant clouds of gas. But scientists say that a much more common model of planetary formation is when dust and rocks gradually accumulate around some kind of core. This proves the idea that there are numerous ways for planets to form. It can also mean that there probably are very diverse planetary systems in our home Milky Way galaxy. But AB Aurigae b isn't the largest exoplanet ever discovered. In 2005, astronomers spotted a mysterious space body. Later, they called it GQ Lupi b. The thing was orbiting a young star at a distance 2.5 times greater than that between the Sun and Pluto. Scientists came to the conclusion that the object was either a planet or a brown dwarf, which is basically a tiny star. If astronomers decide that GQ Lupi b is a planet, it will be the largest ever found, with a radius that is 3.5 times that of Jupiter. The biggest star we know about is called UY Scuti. This hypergiant has a radius that is about 1,700 times greater than that of the Sun. If you somehow managed to place UY Scuti in the center of the solar system, its edges would stretch far beyond Jupiter's orbit. As for the dust and gas streaming from the star, all this would extend beyond the orbit of Pluto. That's 400 times the Sun-Earth distance. A black hole is a spot in space where the pull of gravity is so strong that even light can't escape it. But why is gravity so powerful there? Because matter is squeezed into a teeny tiny space. Supermassive black holes, which can be many millions of times the mass of the Sun, tend to lurk in the centers of galaxies. The most massive black hole astronomers have discovered so far is TON 618. Its mass is equal to that of 66 billion suns. It was the year 2010 when, with the help of the Fermi telescope, astronomers spotted ginormous something entering the Milky Way. Their discovery looked like massive blobs of matter that could only be observed in particular wavelengths of light. They were also about 25,000 light-years tall. Scientists think that the blobs, called Fermi bubbles, could be produced by our galaxy's central black hole. Space seems to be extremely deserted, but some places are even emptier than the rest, like Supervoid in Eridanus. Astronomers noticed this huge region of empty space in 2004. The area stretches 1.8 billion light-years across. It's mysteriously devoid of gas, dust, stars, and even dark matter. A nebula is a massive cloud of gas and dust floating in space. Some nebulae form when a star is nearing the end of its life and throws out loads of gas and dust. Others appear in regions where new stars are forming. The largest nebula we know about is the Tarantula Nebula. In its longest span, it measures over 1,800 light-years. This nebula, also known as 30 Doradus, is located around 170,000 light-years away from Earth. Unlike its namesake, the Tarantula isn't dangerous. Quite the opposite. It's a stellar nursery, which means it's a region where tons of young stars are born. Even cooler, it's the most active star-forming area in our entire galactic neighborhood. In 2021, the biggest ever comet we know about entered our solar system. It was 85 miles across, and its icy nucleus was 50 times greater than the nucleus of the previous record breaker. The intruder's mass was a whopping 100,000 times bigger than that of an average comet. In fact, C 2014 UN 271 Bernardinelli Bernstein was so large that astronomers first classified it as a minor planet. Is it going to crash into Earth? Nah, it won't get closer than 1 billion miles to our beautiful green planet. And it won't happen until 2031. But could there be comets even bigger than that? Who knows? But the thought is terrifying. There are loads of bizarre things in the universe, and hypothetical nuclear pasta is one of them. If it does exist, nuclear pasta is the strongest material in the entire universe. It forms from the leftovers of extinguished stars when this substance gets squeezed into spaghetti-like tangles of material. It can theoretically break, but only if you apply 10 billion times the pressure needed to shatter steel. Pulsars are spherical space objects the size of a large city, but they pack more mass than the entire sun. They radiate 2 narrow beams of lights, sending them in opposite directions. The Black Widow pulsar, just like its spider namesake, is munching on its partner. It's a lightweight brown dwarf star. The more material the pulsar consumes, the more slowly it spins. The energy the neutron star is losing in the process causes its companion star to dwindle. Haumea is a dwarf planet orbiting in the Kuiper Belt, a donut-shaped ring of objects around the Sun that extends just beyond the orbit of Neptune. The mini-planet has a bizarre elongated shape and 2 moons. The day on this planet lasts just 4 hours, which makes it the fastest spinning large object in the solar system. But the most mysterious thing about Haumea is that the planet has a thin 40-mile wide ring circling it. What is it? Where did it come from? No one knows. Could be the result of a collision that happened in the distant past. The 18th brightest star in the night sky, Fomalhaut, is a terrifying sight. It's dubbed the Eye of Sauron because of a ring of dust and debris circling it. It makes the star look like a giant eye staring into your soul. The intimidating star is more than twice the mass of the Sun. It's 25 light-years away from Earth, which isn't that far away, considering distances in space. Look at this butterfly. Its wingspan is more than 3 light-years. And the structure inside this nebula is one of the most complicated ever observed. The nebula's central star, a white dwarf, is heated to an incredible 450,000 EJ/F. It means it was formed from another gargantuan star more than 5 times the size of the Sun. The white dwarf is surrounded by a thick disk of dust and gas at the equator. That's what probably makes the whole structure look like an hourglass, or a butterfly. Locating the North Star is quite easy on a clear night. The only thing you need to do is find the Big Dipper. Those 2 stars on the end of the Dipper's cup point the way to the North Star. See? It's the tip of the handle of the Little Dipper, or the tail of the Little Bear. It's in the constellation Ursa Minor, over there. People have been watching the North Star for centuries. This bright star is also known as Polaris. It's situated almost directly over our planet's North Pole, which makes it a great landmark for a traveler without a compass, or GPS on their smartphone. It's also Earth's closest Cepheid. That's what we call a star that pulses regularly in brightness and diameter. Polaris is also part of a binary system of 2 stars. It's got a dimmer sister. It's known as Polaris B. You can actually see it circling the North Stars from Earth. But the more astronomers watch Polaris, the less they understand. The problem is, no one can agree on how big or distant the star is. Scientists have several ways to estimate the mass, age, and distance of a star like Polaris. One method is called the stellar evolution method. After studying the brightness, color, and rate of pulsation of a star, experts use this data to figure out how bright or big it is, as well as what stage of life it's in. Once these details are clear, it's not hard to find out how far a star actually is. It's simple math once you know the luminosity of a star in real life and how dim it looks from our planet. Such models are especially precise for stars like Polaris because the rate of their pulsing is directly related to their brightness. This makes it easy to figure out the distance to any of those stars. Astronomers trust this method so much that Cepheids have become an important tool for measuring distances all across the universe. At the same time, there are other ways to study the North Star, and they don't agree with the stellar evolution models. Polaris is a so-called astrometric binary. It means you can see its companion going around it. It looks as if a circle is being drawn around the bigger star. To complete one orbit, the smaller star needs around 26 years. Even though astronomers haven't made detailed observations of Polaris B's full circuit, they've seen enough to know what its orbit looks like. Using this information, one can apply Newton's laws of gravity to calculate the masses of the 2 stars. Combined with the Hubble Space Telescope's new measurements, these calculations lead to very precise numbers. Polaris is supposed to be around 3.45 times the mass of the Sun, but that's much less than the mass you get from stellar evolution models. They suggest a value of almost 7 times the mass of the Sun. But there's another reason why this star system is weird. After calculating the ages of the stars, researchers concluded that Polaris b is much older than its bigger sibling. But it's extremely unusual for a binary system. Normally, both stars are of the same age. One explanation might be that at least one of the measurements is simply wrong. After all, Polaris is a difficult star to study. Since it's positioned above our planet's north pole, it's outside the field of view of most telescopes. As for those telescopes that do have the needed equipment for measuring the star's properties precisely, they're typically used for studying much more distant and fainter stars. Polaris is simply too bright for such instruments. It blinds them. There's a theory that the main star of the Polaris system was once two stars, but they collided a few million years ago. Such a binary collision could rejuvenate stars by pulling in extra material and making the stars look as if they went through the fountain of youth. It would also explain some other oddities, since stars that appear as a result of binary collisions don't fit stellar evolution models. Unfortunately, so far, none of the theories has been confirmed. The North Star is actually a big deal. Earth is spinning non-stop, which causes the sun to rise and set and stars to travel across the sky. Our planet is also tilted. That's why we have seasons. If we drew a line through the axis, Earth spins around and extended it for over 300 light years past the North Pole. At the end of that imaginary line, there would be the North Star. It stays almost exactly at the same spot in the sky at all times and always points the way north. It's really important for navigation. People heavily relied on it in the days before GPS. If you were standing on the equator, Polaris would be right at the horizon. At the North Pole, it would seem to be right over your head. In other words, using the star's height in the sky, you can not only figure out the needed direction, but also understand where you are on Earth. Curiously, there's no South Star. There isn't a bright enough star right above the South Pole. But one day, we might get such a star. When you spin a top on the table, its end moves in a circle. We know this phenomenon as precession. Earth behaves in the same way, and the North and South poles won't always point toward the same spots in the sky. In the next 26,000 years, it may cause the North Star to change from Polaris to a few other stars and back again. One day, the title of the North Star will go to Vega. It's the fifth brightest star in the night sky and the second brightest in the northern celestial hemisphere. Vega has another name, Alpha Lyrae. That's because it's the main star of the Lyra constellation. Vega has been one of the most crucial stars to people since ancient times. It's very bright and blue, hence very recognizable. Vega was the North Star several thousand years ago, and it will regain this status in 12,000 years or so. This star is located a mere 25 light years from Earth. It's just 450 million years old, which makes it way younger than our own 4.6 billion-year-old solar system. Astronomers study Vega to learn more about star systems in the early stages of their formation. Vega is almost directly overhead at mid-northern latitudes on a summer night. It hides behind the horizon for only 7 hours a day. You can see it on any night of the year. If you travel farther south, you'll find out that Vega lies below the horizon for longer periods of time. But in Alaska, northern Canada, and some parts of Europe, Vega never sets. Vega's blue-white light is bright enough to be featured a lot in ancient cultures, from the Chinese to the Polynesians to the Hindus. Vega's name can also be translated as falling or swooping. This is a reference to the times when people regarded this constellation as a swooping vulture, not a lyre. Vega was also the first star to get photographed, other than the Sun, of course. To do it, astronomers at Harvard College Observatory used a 38 centimeters refractor, and it happened in 1850. Around 2 decades later, an amateur astronomer broke down Vega's light to reveal various elements making up the star. In 2006, thanks to telescopic observations, scientists found out that Vega was whipping around so fast that its poles were several thousand degrees warmer than its equator. The star rotates every 12.5 hours and is at 90% of its critical rotation speed. That's the velocity at which an object can tear itself apart. In 2013, researchers announced that they had discovered an asteroid belt around Vega. It means there might be planets somewhere out there among space rocks. There are two areas: an outer region that contains icy asteroids and an inner region with warmer space rocks. Scientists can examine bright stars like Vega using NASA's mission called TESS, which stands for Transiting Exoplanet Survey Satellite. It was launched in 2018 to conduct an all-sky survey. The main goal of this mission is to search for exoplanets, but the satellite can also look for star variability. By examining such stars as Vega, TESS can help scientists learn more about the early stages of star evolution. This planet, yeah, this one right, shouldn't exist, but it does. A newly discovered planet rotates around a star that's much smaller and dimmer than our Sun. The planet, however, is enormous. Such a tiny star couldn't create it, so it's like finding an ostrich egg in a chicken coop. A team at Penn State built a special tool called the Habitable Zone Planet Finder. It's an instrument that's supposed to find planets around dim, cool stars. It's connected to a big telescope in Texas. The tool looks at the light from these stars, which is mostly in the near-infrared, beyond what our eyes can see. This gadget can spot changes in a star's speed caused by a planet. If a star movement slightly changes, that means there must be a gravitational pull nearby. Years ago, this technique helped find the first known exoplanet around a star like our Sun. Today, we improved this method to make more precise measurements. Our main goal is to find Earth-like planets. They should be rocky and located in habitable zones, areas around stars where liquid water could exist. The Doppler technique isn't that great at finding Earth-like worlds yet, but works well for cool, dim stars. That's how we discovered the impossible LHS 3154b. Planets usually form in disks made of gas and dust in space. Picture a flat, spinning cloud of tiny particles. These particles come together and stick to each other, creating a flat, rotating disk. Over time, these tiny bits combine to form a solid core. This is a starting point for a planet. Once the core is there, it attracts more dust and even gas like hydrogen and helium. But making a planet this way isn't easy. They need a lot of stuff, mass and materials. This process is called core accretion. Stars are a huge help in that process. Normally, big stars have more gravity, so they can gather more stuff to form planets. But the star we discovered recently isn't very big. It's 9 times smaller than our Sun. A star this small shouldn't have a big enough disk to make a heavy planet. To do that, its disk should have been at least 10 times bigger. But this heavy planet, LHS 3154b, exists. This mysterious planet is 13 times heavier than our Earth. It's similar in size to Neptune. It's about 50 light-years away from us in the Hercules constellation, which in space terms is very close. The planet is also super close to its star, completing 1 year in almost 4 days. This discovery is making scientists rethink their ideas about how planets and stars come into existence. There are new theories coming around. For example, a theory called gravitational instability. It says that, instead of the pieces coming together bit by bit, the material in the disk collapses all at once, directly creating a planet. But even with this theory, it's hard to explain how such a heavy planet could form without a really massive disk. It will take us some time to figure out the truth. This isn't the first planet that makes us doubt our theories. Recently, scientists found another planet called Hala. This planet is orbiting a star called Baek-Du, and just like the previous one, it shouldn't really exist. It's way too close to its star. Stars change a lot during their lives. Normally, when a star becomes big and prepares to leave this world, it's called the red giant stage. A star like that tends to destroy or push away any nearby planets, creating a huge mess. Hala rotates around a red giant, and it should have been swallowed or destroyed by the expanding star a long time ago. But it's still hanging there. Even though Baek-Du has already started burning helium and shrunk to a smaller size than expected, Hala isn't bothered in the slightest. Scientists call Hala the Forbidden Planet. This discovery challenges what we thought about how planets survive near aging stars. It raises 2 theories. One suggests that Baek-Du was once 2 stars, a white dwarf and a red giant. Hala orbited them both, and they merged before the red giant fully expanded. This allowed Hala to survive because the extra helium from the white dwarf prevented the red giant from growing too much. The second theory says that Hala formed from the debris created when the two stars merged. In this scenario, Hala would be a very young planet orbiting an elderly star. Astronomers plan to continue studying Hala and look for more planets like that. Another oddball is called LTT 9779b. This one scares us because it's too shiny. This planet reflects 80% of the light from its star. Regular mirrors reflect from 85 to almost 100% of light, which means that this mysterious planet should look like a rough mirror, with aluminum or silver-like reflections. This is another Neptune-sized planet. It's located 260 light-years away from us and was discovered by NASA's TESS spacecraft. It completes a full rotation around its star in just 19 hours. It's so close to its star that it's scorching hot, reaching temperatures over 1,982 degrees Celsius. Normally, planets this close lose their atmosphere and turn into bare rocks. But this one breaks the rules again. This time, we know the secret of its survival. It's because of the planet's shiny metallic clouds, which are made of glass and titanium salt. These clouds rain titanium onto its hot surface. They also reflect a lot of light, preventing the planet from getting too hot and losing its atmosphere. It's like having a mirror shield. This planet's size also surprised scientists. It's way bigger than Earth. Other planets this close to their stars are either much bigger gas giants or small rocky planets. This planet is a smaller gas giant, and scientists didn't expect it to exist so close to its star. This is the shiniest planet ever found, even shinier than Venus, but despite its cool appearance, it's probably not a friendly place for life because of its extreme temperatures and strange metallic rain. And our final rule breaker is a planet called WASP 107b. Scientists discovered it using the James Webb Space Telescope. It's located around 200 light-years away from us in the Virgo constellation. It's also fast and completes an orbit around its star in just 6 days. This is a super Neptune exoplanet. It's similar to Jupiter in some ways, including the same size and scorching hot temperatures. But the main difference is that it's much lighter, weaker, and less dense. This is the least dense planet we've discovered so far. After researching some more, we also found that it has a tail. The helium on the planet extends beyond the transit egress. The planet is slowly losing its atmosphere due to extreme ultraviolet radiation from the star. This creates a comet-like tail. So, it looks like a fluffy comet. But that was just the beginning. The planet's low density, or fluffiness, allowed astronomers to study its atmosphere in detail. They found some surprising things, like water vapor and clouds made of fine silicate particles, which are like really fine-grained sand. The planet's host star doesn't emit a lot of high-energy light, but since WASP 107b is so loose, the light can penetrate deep into its atmosphere. This creates sulfur dioxide, that smell when you light a match. In other words, it's a fluffy planet that rains sand and smells like matches. The researchers think the sand clouds in the atmosphere form in a similar way to clouds on Earth. They just have droplets of sand instead of water. These sand droplets condense, fall, turn into silicate vapor in hot layers within the planet, and then rise again to form clouds once more. And once again, this planet couldn't have formed in its current spot. Astronomers say that it likely moved closer to its star from a birth orbit because it was attracted by some heavier neighbor. It also follows a retrograde orbit, meaning it orbits in the opposite direction to its star's rotation. All these discoveries are changing how we understand planets and their atmospheres, giving us new insights